Hello guys, today I'm going to show you how to basically find out what's the temperature inside of a transformer when it is like loaded heavily down or something. In this case we will arc with it. You can see the formula in front of us. Let's first go to the transformer and I will explain. For example, we have here a 3.5 kilovolt high voltage transformer. Now let's say we are arcing with it and we want to know what's the temperature inside of the windings. So you can see they're like epoxied in, so you cannot access the windings. There's a lot of like fibrous material and resin and stuff in between the windings and the surface, so you don't know the temperature. Now there is a way to measure it, and that's with the resistance of the windings. What you first do, you measure the cold resistance at about room temperature, 20 C, but in this case it's a little bit warmer here, but it's a little bit off the measurement, the result, but it's okay. First make sure it's unplugged, then you do, as you can see, about room temperature. Ideally it would be 20 C, but yeah. Measure the resistance with a multimeter. Wait until it's stable. I would say it's stable, so it's 98.3. 98.3. So now we will write this down. So I first now write down the cold resistance, arrow 98.3 ohms. Now we will arc for a while and see the increase in resistance, and we will then measure R2, the hot resistance, or after the run. As you can see, I now plugged it in. I will turn on the power. .240 volts. Now remember that the transformer is ballasted, so we can do this for a very long time. We turn off. Now remember, we was running through a ballast, that's why we can run for a very long time. We will now unplug and measure the resistance again. I now reconnected the ohm meter and now it says 99.6 ohm, a slight increase. 99.5, let's say 99.6. Again, remember it didn't heat up a lot because we are ballasted very much, so the total power across the transformer is not that great. So 99 point, see, it is dropping because it's cooling down. 99.6 was, so we're going to go back to the paper. Okay, we are back at the paper. Now we can use this formula. As you can see, it would be temperature winding rise is R2 divided by R minus 1 divided by 0.00393, that's the coefficient for copper. For aluminium it would be this one. I will write this formula down and use the calculator, and I will be right back. So now after we calculated this, as the formula shows, and we got 26 as, let's say, the room temperature, we know that the temperature inside of the transformer is 29.36 C. So it's like 3.36 degrees above ambient. Now it's a very small increase because we didn't only run it for like 2 minutes, 2 minutes, and again very ballasted. The active power was only like 500 watts. The reactive power was like much greater because it was 15, 16 amps. And if it would be unballasted and we would draw like say 35 amps from the mains, the winding temperature would increase quickly. But yeah, that's like a practical example of how to measure the internal temperature of a transformer or inductor or ballast or whatever has a wire in it, basically relay, contactor, you name it. Yeah, thanks for watching, and I have a little bit of a cold, sorry for the voice. Yeah, thanks for watching and see you soon again. Bye.